Hiya 12s, it's Mr. Lim here again, and oh my god, what happened to my third column? Oh my goodness, what happened to all my videos? Oh, must not be making them later. Okay, so we're going to be learning about the production of ethanol, and we're going to, because Mr. Lim hasn't totally just cut and pasted this from another one. You didn't see that sulfuric acid there. Alright, so production of ethanol, let's get into that. So, we can do it with two different processes. One is the hydration of ethene, and the other is the fermentation of sugar. Okay, so let's start with the hydration of ethene. Okay, so ethene is C2H4 and water is H2O. Duh. Okay, so this is the reaction C2H4 plus H2O goes to C2H6O. Okay, and effectively it's just that double bond gets broken, and then you end up with a H on one end and then the OH on the other end. And that's fairly straightforward. Okay, that should be fairly simple to know. Alright, it is an exothermic reaction. Okay, and the forward reaction produces less gas particles. Okay, so those are kind of things to remember when we deal with rate and yield. Okay, so it is a continuous process, which means that the mixture is continuously pumped in and removed at the same time. Okay, and it is an addition reaction, just in case you've forgotten what the name of that particular reaction is. Okay, ethene is from fossil fuels, which means it's not a renewable resource, which is not great, but it happens. And it's put into the reaction chamber with phosphoric acid as the catalyst. So sometimes, be like, what's the catalyst? And you'd be like, phosphoric acid, that's what it is. All right, so let's get to the conditions. So the gases ethene and water are heated to 270 to about 300 degrees Celsius using that furnace there, over here. All right, and then in goes into the reactor. That temperature is high enough to get a good rate, but remember, because it's an exothermic reaction, you make it too high and you won't get a good yield, so it is low enough to get a good yield. Alright, so effectively it's a compromise in temperatures where you can get a good rate and yield going at the same time. And remember, because it's a continuous process, the rate is much more important than the yield, because this thing actually runs at like 5% yield every single time it goes around. And so therefore, since you're going to continue to do it, it doesn't actually make that much of a difference to the yield. Okay, pressure of about 6,000 to 7,000 kilopascals, which is quite high. All right, remember, it is the forward reaction produces less gas particles, so high pressure is what you want for both rate and for yield. What limits your pressure? Not going to blow up the reactor, so that's important. Okay, so the gaseous mixture is passed through a cooling chamber in which the ethanol and the water are condensed, and unreacted ethene is returned to the chamber. Okay, so remember, waste not, want not. You've got an exothermic reaction. This water out of the coolant is going to be hot, and so therefore you can use that heat to power some stuff, maybe like electricity, so that you don't use so much electricity in this process. Okay, so that's the idea for the production of ethanol. Those are those compromise conditions, or only for the temperature. And remember, you're trying to use everything. Again, you should be able to explain why water and ethanol will liquefy at a much higher temperature than ethene, with all those van der Waals forces. Alright, so production of ethanol via the other way, the fermentation of sugars. That's how you make your moonshine. The glucose broken down into ethanol and carbon dioxide. Okay, so where's the equation? So here's your glucose, C6H12O6. Okay, it's broken down into ethanol, C2H6O, and it's broken down into two of them, and 2 carbon dioxides. And I think that's enough atoms of everything. Yes, perfect, there it is. Okay, so that's the equation for the breakdown of glucose into ethanol, produces carbon dioxide as well. Okay, so carbon dioxide there. Okay. Reaction is usually performed by live yeast. So what you do is you put your grain mixture or your sugars and stuff like that, you shove it in the fermentation tank, you drop some yeast in there, and then you let them sit. Okay, so the enzymes in the yeast break down the glucose. That glucose turns into ethanol and carbon dioxide. That carbon dioxide will float because, it's a gas. I don't know why they put the CO2 at the bottom, right? And so therefore they collect it at the top, and the mixture just sits in there for a while. Okay, it uses renewable raw materials, which is useful, and so therefore it is a renewable resource, is slightly more green. Okay, it is a batch process. Okay, so what happens is that they sit in there and they have every batch has to be then processed, and then they have to refill the fermentation tank and then do it again and do it again and do it again. Okay, so couple of ideas. Glucose mixture and yeast is placed in the reaction chamber and oxygen is removed, so make sure that it's not like cellular respirized in the other way to make carbon dioxide and water, but instead to make ethanol. All right. Then the reaction continues until the concentration of ethanol is too high and the yeast organisms to survive, and then they all die. All right. So every time you drink some wine or some beer, just remember all of the lives of those yeast that died just so that you could have that drink. All right. So effectively, the concentration of the ethanol gets higher and higher and higher and higher until it becomes too high, and then the yeast don't survive, and then they all die, and then that's when the reaction ends. Okay, it's performed at biological temperatures and atmospheric pressures to not kill the yeast. Okay, the yeast do their thing. They don't need to be heated up. And then the mixture is then purified by distillation to get a very pure ethanol. Okay, so you take out all that stuff, you distill it, the ethanol comes out first, and you catch that stuff, and then you get a very high percentage ethanol solution. All right, other waste products are used for other things. That's always useful. Waste not. Okay, so this is just comparing all the processes of production of ethanol. The temperature, again, you use low temperature versus a high temperature, normal pressure versus high pressure, which means that save the money. Okay, so you don't have to spend so much money. Catalysts, it's amylase and cellulase, but it's effectively the yeast enzymes, or the enzymes within the yeast that do the work, whereas you have the phosphoric acid there. Purification, you have to use a couple of distillations to get it right, because the mixture is actually pretty terrible. And then this one here, you don't need much distillation because it's just separating the water from the ethanol. Raw materials, plant material. Ethene from crude oil, that's bad. Okay, not renewable. And this one here, the fermentation process, is much cheaper than the hydrolysis of ethene. In fact, that's where the majority of the world's ethanol comes from, instead of the hydrolysis of ethene. Okay, couple of things. Actually, no. I'll leave that for the next slide. Okay, so the production of ethanol, the links to other things, green chemistry, you're using renewable resources if you use the fermentation method. You use enzymes to save energy if you use the fermentation method. If you do use the hydration of ethene, you should ideally use the heat produced from the exothermic reaction to power the plant. And you use all your waste products in the fermentation process, so like the solid CO2 and the solid waste, the CO2 and the solid waste should also be used, just to make sure that you're using everything. All right, we have some equilibrium considerations with the hydration of ethene. And you have your organics ideas of the fact that you're actually making an alcohol, what that alcohol could be turned into, testing the purity of it using VA if you have to. Just those are the ideas that you can link to the production of ethanol. And that's about it. Adios.